We're now going to examine something called the regression effect and talk about why this word regression is used in this context. And we are going to focus on the football-shaped scatter diagram sloping up. And what we have observed is that if you're given a certain number of standard units in X, then your prediction is not quite that many standard units in Y. It's a little bit less. And that is called the regression effect. Those who have high values of one variable tend to be not quite as high on the other. The key here is tend. In general, they're not quite as high. On average, they're not quite as high. Of course, some people will be very high in both. But on average, they're a little bit less high on the second variable than on the first. Why does that happen? That happens every time you have any spread about the perfect straight line. If your scatter diagram is not a perfect straight line, which in any real application is going to be the case, unless you're doing something a little bit artificial. If there is any spread about the line, then you will see the regression effect. And we saw that with the geometry of the oval. The equal standard units line was not picking off the center of the vertical strips. So the only reason for that is ordinary variation, especially of human beings. We do not perform the same way on two variables. It's as simple as that, and in some sense, it's as boring as that. Who observed it? It was an astonishing man called Sir Francis Galton, turn of the previous century. This man was a scientist in many disciplines, cousin of Charles Darwin, by the way, and in statistics, he has some phenomenal contributions. The SD, the correlation, he didn't invent that, but he certainly figured out how to use it, and this method of regression is entirely due to him. Why? Because he was a eugenicist. Eugenics is this idea of breeding Superman, which is, in my view, a diabolical idea and really has no place in the world. Well, that's my personal opinion. Galton disagreed. But for all that we would have hated each other as people, I have to say I admire him as a scientist. Because he gathered a lot of data and he made some extraordinarily perceptive observations. And one of the things he observed was, well, he wanted to see how height was passed down from one generation to another. And so he looked at fathers and he looked at sons. And he noticed that fathers who are tall tend to have sons who are not quite that tall, on average. And that's what we have been saying is the result of how the ellipse is shaped. So what did that do for him? Well, not much. It did exactly the opposite of what he was trying to do. He was trying to breed Superman, and Superman apparently has to be tall. So he has a tall father, he looks at all the tall fathers, and he looks at their sons, and he wants them to be tall. Well, they are tall, but not quite as tall on average as Dad. This was not satisfactory to Sir Francis Galton, and he termed it regression to mediocrity. And that name stuck, because it shows exactly what is going on in the estimate. You started a certain number of standard units, your estimate is a little bit less than that. Now, on the other side, if you started with the short fathers, then their sons would be on average a little bit taller than them. But Galton didn't care about that. He was trying to breed Superman, and he probably thought that short people shouldn't have children in the first place. I don't know that he thought that, but I wouldn't be surprised. But still, the observation is that you start out high on one variable, your estimate is going to be somewhat less high on the other. Correspondingly, if you start out low on one variable, then your estimate is going to be somewhat higher on the other, and so you have what is commonly known as regression towards the mean. And this is something that, as we've said, happens every time there is spread about a straight line, but people love to want to give it a reason. And so we're going to talk about the regression fallacy. Fallacy is an error, a mistake. It's a mistaken interpretation of what's going on. Thinking that the regression effect is due to some external cause, which is different from just ordinary variation. And a classic example of this is something called the sophomore slump, which in various other cultures is called the second-year blues or second-year syndrome, and it's often applied to athletes who in their first year do extremely well. For example, in baseball, the rookies of the year, the rookie is a first-year player, and so rookie of the year is a first-year player who does better than every other first-year player. And people are very interested in following these players in their second year, and do you know, in their second year they don't do quite as well on average. And people get terribly excited about this. Oh, you know, the endorsements went to their head, or they had too many groupies, or if you're in your second year of university, then you slack off. None of that. Because people do not perform the same way time after time, there is spread about a line. And that is what causes the regression effect, nothing else. Trying to ascribe it to some other cause is a mistake and is called the regression fallacy.